So, good evening, good afternoon, or good morning, depending on where around the world you are watching this. This is the 5th webcast for the University of Melbourne's virtual fair. So, welcome and thanks for joining us. My name's Stephanie and I'm going to be hosting this session on teaching and learning at the University of Melbourne. And tonight I've got two special guests. I've got Chong Ng and Will Sidebottom sitting next to me, and together the three of us are going to talk a little bit about the teaching and learning here at the University of Melbourne. So the format for this session will be, we'll give you some information first, we'll have some questions and some answers from my special guests, and then we'll have any of the live questions that you send in to us to answer for you. So I'd just like to introduce my guests. Chong Ng is originally from Malaysia and is now studying here and tutoring at the University of Melbourne. And he's got a Bachelor of Engineering from the University of Melbourne as well as a Master of Philosophy, and is now a current PhD student in Mechanical Engineering. Chong tutors in a subject called Fluid Mechanics, which is one of our undergraduate subjects, as well as a master's subject called Computational Fluid Dynamics. So for anyone out there who's an engineering or science or maths whiz, he might be your man. His PhD topic is looking at convection or heat transfer between a hot and a cold wall, or at least that was how he explained it to me, and it made sense. Will here has a double degree in aerospace engineering and science, so maths and physiology from Monash University, and a diploma in arts and international studies. After that, he did a graduate certificate in commerce at the Melbourne Business School here, and is also a current PhD student in the mechanical engineering department here at the University of Melbourne. His PhD topic is on fluid mechanics, and he's researching predicting sound in submarines. Will tutors in some of the third year subjects, fluid mechanics as well, and another one called mechanical design. In addition to this, Will tutors one of the non-technical subjects in the master's program of engineering called STEP, and that stands for Skills Towards Employment Program, and we'll hear a little bit more about that later. So I'm just going to start by providing a little bit of information about learning and teaching here at the university, just to give you a bit of something to start with. We've got bachelor's degrees, master's degrees and PhDs here. A bachelor degree here at the University of Melbourne is 3 years in length, and it's 8 subjects a year, 4 subjects a semester. You might have done some research on the internet, and the subjects you might have seen have been given point allocations. So 1 year of study at the University of Melbourne equals 100 points, and that means one subject is 12.5 points. This is just a way that the university measures the subjects. Different universities do it differently, but I just wanted to start by explaining that so that you get a sense of what we talk about if you hear us talk about points. So to do a whole bachelor's degree, you'll do 24 subjects in total, or 300 points. Honours years are available, which is a 4th year, or 100 points, and then we have master's level programs after that and PhDs. The curriculum here at Melbourne changed a number of years back, where our professional programs are now taught at the master's level. So we have 6 broad undergraduate degrees, and any of our professional programs, things like law, teaching, engineering, architecture, social work, medicine, dentistry, they're all taught at the master's level, which is one of the unique things about the University of Melbourne's teaching. I'm going to start a bit by talking about contact hours, so the number of hours that you might do as a University of Melbourne student in one of your programs. So if a student takes a program in something like humanities or social science, the number of hours that you might do between your lectures and tutorials, it could be anywhere between 8 to 12 hours in your first and second years. It might go up a little bit in your third year, and that means that you're required to be in lectures and tutorials for that time. If you're in a science or an engineering or a medical based program, you're likely to have more contact hours. somewhere in the vicinity of, say, 16 to 21 contact hours in say, your first year, and it might slightly increase from there. Now, I want to cover off in this session a little bit about the transition between high school to undergraduate, a bachelor's program, and then bachelor's into a master's and a PhD, because our special guests here have got experience from going from a bachelor's degree into PhD and master's programs, as well as also being tutors here at the University of Melbourne. So if you come and study engineering, you might be tutored by one of these two gentlemen. So Chong, if you can, I might start with you. Can you please describe to our audience a little bit about the difference between a lecture and a tutorial?
So typically lectures are formal sessions where students will be in a big classroom and have like FaceTime with the lecturers, and the lecturers will present the main contents of the subject to the students. So the ratio of students to lecturers will be about between 200 to 300 students per lecturer, whereas for tutorials are essentially more informal sessions where you have the ratio of students to tutors between 30 to 40 per class, and that's where you actually go through problems, specific problems targeted at certain topics of the subject which you're taking, essentially. Yeah.
So as a tutor, do you choose the topics, or are they set by the lecturers for the tutorial topics? Are they set by yourself, or how does that work?
They're usually set by the lecturers and sequenced in such a manner that you slowly increase the complexity of the concepts that you learn along the way.
Okay.
Yeah.
So as a tutor, how do you prepare information for the students? So if the topic's been set for the particular tutorial, how do you prepare students for the learning that they're going to encounter? And can you talk a bit about what resources you might use to help the students along?
Yeah. So typically how I conduct my tutorials is for the first 5 or 10 minutes of the tutorial, I will summarize the key subject matter for that particular tutorial session. And with those points in mind, we'll go through the questions together with the students. And during such tutorial sessions, I will sometimes play YouTube clips or any relevant clips from the internet so that students can relate the real-life application to the theories that they learn in lectures.
Great. Do you want to tell us a little bit, we skipped over, I spoke a little bit about what your PhD topic is. Did you want to try and talk a little bit about what it is that you're covering in that?
My PhD topic? Essentially, it's about fluid flow between a hot and cold wall. So essentially, hot air rises and cold air sinks. So I study the physics of that flow configuration, and it's quite interesting to see how it relates to sustainable building design and things like that.
Do you find that your PhD helps with when you're teaching students in the tutorials?
Yes, definitely. The more detail that I guess in a way the rigor that you go through as a PhD student and the materials that you're exposed to, you can actually those are the skill sets which you develop along the way, and you find that with all this fine-tuning of your skills, you can present the material to the students in a much more focused manner so that you know what exactly the students need to know at certain points in the subject.
Fabulous.
Yeah.
So in some of our subjects, there's lectures, tutorials, but there's also laboratory work and a lot of hands-on work. And particularly in engineering, that's really, really important. So Will, I wanted to ask you, for some students in the science, engineering and medicine subjects or programs, they undertake laboratory work. Can you explain a little bit about the laboratory work, how it works and how it might be different from a normal tutorial?
Sure. So laboratory work is practical in its nature. So whereas a tutorial is very theoretical, you're working with equations, pen and paper. Laboratory work's typically using equipment. It might be an engine if you're in engineering, or it might be a frog that you're dissecting if you're in biological sciences. And it's a really good opportunity to learn how the theory that you learn in lectures is applied to real life situations. So it's a chance for you to get your own data or take your own samples and process that data and really learn about what the theory's telling you in lectures.
And with so in a program, it's very common for students to do a number of lectures a week and tutorials as well. How often would a student do a laboratory class?
In some subjects, it's once a week. Like if you do physics or maths, then it's like a computer lab or an experiment once a week. For other subjects in engineering, it's 3 or 4 throughout the semester. So it differs quite a lot depending on the subject and what stage of your degree you're at.
And is there a focus on group work in the laboratories?
Yeah, definitely. So because there's only so much equipment that we can provide for the students, so there's a lot of group work, which is good because you learn teamwork skills and leadership skills and all the rest of it. So yeah, you do get to work in groups and you also learn a lot from each other as well.
That's fabulous, thank you. One thing I didn't mention that I'd like to touch on now is just something to do with some of the resources that we provide to students to enhance teaching and learning here at the University of Melbourne. As a student, you'll all have access to what's called the Learning Management System, or LMS. There's lots of acronyms here at the university, so you'll get used to those. And the Learning Management System, or LMS, has all your subjects on it, and often you can download subject notes or even view lecture recordings and video of the lectures that you've attended. So if there was a concept that you had learnt and it was a little bit hard and you wanted to go over some of what the lecturer covered, you can log on to the LMS at the completion of your lecture and watch it over and over again. So it really helps with solidifying that learning. You can also then lean on the tutors that you've got, so you can come to a tutorial and ask them if you had ask them questions or to help clarify any of the information that you might not have understood properly. So that's a really great resource for students to be able to use. Now, Will, I'll ask you another question. I briefly mentioned STEP when I introduced you, the Skills Towards Employment program. Can you please explain to the audience tonight a bit about what STEP is and how it benefits the students that study it?
Sure. So STEP is specifically for Master of Engineering students, and it's designed to improve their written and verbal communication skills. So written and verbal communication are really important when you become a professional engineer, and they're skills that employers really look for in their graduates when they're employing them. So they're not taught explicitly in your typical engineering subjects. So the STEP program, Skills Towards Employment, is run in parallel to your standard curriculum, and it helps develop those skills that you don't necessarily get in the other subjects. So it's particularly for students from a different country for whom English isn't their first language. It's a really valuable program to help develop your verbal and written communication skills that you need when you become an engineer. So,
is there any group work involved, or is it mainly one-to-one or individual?
Yeah, so there's a bit of group work where we talk mainly about preparing substantial technical written reports and also giving technical presentations. So in doing that, we do a bit of group work, but it's also pretty like me and 2 or 3 other students at a time. So it's quite focused and yeah.
Oh, that sounds great.
Yeah.
So certainly a lot of support here to be able to solidify your learning of the technical side of things, but as well as preparing students for careers, which is really important. So these two are both studying PhDs here at the University of Melbourne and tutoring as well. And so I'm going to ask you both, Chong, perhaps you can go first. Undertaking a PhD means that you gain a really strong understanding in one particular area, and in your case, in engineering with fluids. But can I ask you to cast your mind back to before you started being a tutor here, and to talk a little bit about the transition from, whichever you would like, but say from your high school program in Malaysia to an undergraduate program, or then transitioning into a master's or a PhD, and how you dealt with the different learning or teaching techniques along the way, and any advice that you would be able to give to our listeners as to how to cope with that.
Yeah, sure. So I studied my high school and my pre-university in Malaysia before I came over to Australia to do my undergraduate. So essentially it's definitely a big difference in learning culture back in Malaysia. So I guess for potential students, when you come over here, you have to keep an open mind that you are definitely learning in a different culture, and don't be afraid to always ask questions if ever in doubt, and always speak to your peers also if you are a bit hesitant about asking questions to the lecturers. And when I transitioned from an undergraduate to a master's, you have to sort of learn things from not quite from the beginning again, but there are programs or subjects which you have to take as a master's student, which help you transition into the master's, the full research master's program itself. So there are definitely a lot of small little steps that you have to take along the way before you finally realize yourself as a full master's or PhD student. Yeah.
Fabulous. So some good advice there. The students and staff and teaching staff are here to assist you. They're really, our aim is to have you succeed and be the best engineer, doctor, physicist, mathematician, lawyer that you can be. And so to really, good advice there, to really speak up, ask questions, because someone will be there to help you. And if someone immediately can't help you, they'll be able to find someone who can. So that's great advice. Will, what advice would you give to someone in a transition phase, or if you could be an undergraduate or a postgraduate student again, what advice would you give?
I guess I'll start with the transition from high school, as we call it in Australia, to undergraduate. I found that it's a big step up in how you have to learn at uni. It's very individual. You have to sort of learn how to learn. And whereas at high school, your teacher sort of shows you the way, the whole way. At uni, you're sort of given material and you're expected to learn it yourself. But as Chong said, you can ask your tutors, your lecturers, and they're there to support you. But you really do need to learn how to learn yourself early on in your undergraduate degree, and then that'll help you in your later years.
Again, good advice. With an undergraduate program, the subjects in your first year or generally in the first semester are a little more introductory. They do get harder very quickly, and you'll understand with our entry requirements that we do require some very bright students to come and study here at the University of Melbourne. So questions actually come through, which I'll touch on just now, in terms of A-levels requirements and what's necessary to gain entry into the programs here at the University of Melbourne. So it does differ depending on which program you're interested in, but for something like the Bachelor of Biomedicine, students are looking at needing an A and a B. For something like the Bachelor of Science, it's a B, a C and a C. Something like Bachelor of Environments is the same, B, C, C. And for Arts and for Commerce, it's A, B, C. One of the things at the University of Melbourne with entry requirements is prerequisite subjects, which are really important. So these are subjects that you have to have taken in your A-levels or whatever high school curriculum you undertake. So as well as meeting prerequisite the grades, you also need these subjects which will help you to gain entry. And in addition, students must all meet the English language requirements. So thank you to Fard who asked that question. I hope that answer was suitable for you, but you can also check those entry requirements on our website. Let me just see what other questions we've been asked tonight. So this one is not directly related to learning and teaching, but there's a question from Annika about financial aid for international students. We have a financial aid office, and it's given out, financial aid is provided to students once they're here in differing ways. We do also have a range of scholarships for incoming students, but that's actually our next session. So if you want to stay tuned, we'll still be here for another 5 or so minutes, but if you wanted to stay tuned for the next session on scholarships, there'll be more information on that for you then. Something I want to mention that has just sprung into my mind with the University of Melbourne is something called breadth studies. So another feature of the Melbourne curriculum is what's called breadth studies. They're essentially compulsory electives that are part of your 3-year program. You must take a minimum of 4 or a maximum of 6 of these breadth studies, and they're subjects that are designed to complement your existing major or program. So they must be taken outside of your core discipline. Let's say, for example, you're coming to the university to do a Bachelor of Science, and that's your core area. You might take breadth subjects in the arts school, something in communication or a language, for example. And that way you can complement your skills in the scientific area with, say, some writing skills or skills in a different language. So that's one of the benefits here at the University of Melbourne, is that you can combine those subjects together within the same degree. Similarly, if you're taking an arts program, you might be interested in some business subjects, or economics or finance, and you can take those from the business school in your breadth studies. So it's a really good way of broadening your knowledge base, and as well as doing your core area within the one program. If you gentlemen were able to go back to a bachelor's program, what breadth subjects do you think you'd take? Have you ever thought about that?
Yes, sure. I'll definitely pick up some common subjects, definitely about finance and economics, sort of, so you can relate to the real business side of things. Especially as an engineer, you do a lot of engineering, but once you get out into the world and go into consultancy, you definitely want to know a bit more about the business aspect of things and how it really ticks, I guess.
Yeah, for me it was to get into engineering. Obviously, you need to study a lot of maths and science in your high school education, so it was trying to look for stuff outside of that, so history or religion or business and economics, as Strongchen said. So it's just things to complement your education and diversify your knowledge base, and that's really important when you're trying to gain employment at the end of your degree. So yeah.
I think it's a great feature of the programs. One of the other things to talk about is the problem-based learning that takes place at the University of Melbourne, which is a really good feature, where often in a range of different classes problems are provided, and they might be real-life problems. It might be an industry project or problem that's been given to the university for students to solve, or it might be a research problem within the university that is given to students to work on in their tutorials or in different projects that they do. Problem-based learning is great because you really apply the learning from your lectures and your tutorials to real problems, and that make a difference. So it's the benefit of seeing the solutions to what you come up with is immediate, and Melbourne has a real commitment to community engagement and making a difference with all of the teaching and research output. So that's fantastic. Okay, let's see if there's some other questions here from anybody tonight. Someone wanted information on the field of electronics and telecommunications. So this is from Sapna. Thank you for your question. I wanted information on postgraduate studies in the field of electronics and telecommunications in Australia. Does anyone want to have a go at answering that question?
I don't know too much about that. I know there's a strong electronics and electrical engineering group at Melbourne, and we often get invited to seminars that are presented by preeminent researchers in that field, but the specifics of the field I'm not sure.
That's a good point. So we often have visiting lecturers and professors that come, or even our own professors here at the university that do run seminars where students are invited. They're free to attend, and students can come and listen to the latest research that might have been released or learnt from a particular research project or group, as well as just being able to have the opportunity to mingle and network with some of the staff at the university, and this happens in a range of different departments all over the university. So that's another way that you can enhance your teaching and learning, by getting engaged with public lectures, seminars that take place. They're either at lunchtime, some of them happen in the evening, and in a range of disciplines. We have musicians that are constantly performing as practice to lunchtime audiences, and it's just fantastic to really see students engaging other students and playing in front of their peers to what they might have just learnt recently. So it's a really great atmosphere and a great curriculum and place to be involved. Well, I think that might be all of the questions that we've got tonight. We've covered off most of those, which is fantastic. So I'd like to thank my two guests for joining me here tonight or in the morning if that's what time it is for you. The next session, as I mentioned before, is on scholarships here at the University of Melbourne, and my colleague Brett will be taking that webcast with a range of special guests as well. So please feel free to tune into that. And we'll also be answering questions all throughout the night. So if you're sitting out there listening or in one of our booths currently, thanks for being with us and keep sending those questions through. But from us, it's good night. So hopefully we'll see you here at the University of Melbourne.